This toy is called simplest DC motor. Technically it is called homopolar motor. It requires a sail, a screw, a strong magnet. It's called rare earth magnet or neodymium magnet, and a small clip. First I take, and of course a piece of wire. First I take a screw and put it on a magnet. Then I attach screw to the positive side of the cell, that is where this small button is there. Then I place this pin so that the motion of the motor is clearly visible, and then I join the negative of the pole, negative of the battery and the magnet. I join this, and what I get is a beautifully turning electrical motor, turning very high speed. It can turn up to 10,000 RPM, they say. Now why this motor should rotate? Now here is the play of the magnetic field, the current, and the force experienced by that current. Now the magnetic field or the magnet is parallel to the magnet, axis of the magnet, or I can say that the direction of the field is shown by the hand. Now the current flows through this screw and travels through the magnet to the point where the wire touches the magnet. So if this is the magnetic field, then this is the direction of the current. Now if this is so, then the current will experience a force, and the magnitude of the force depends on angle between these two vectors, namely magnetic field and the current. When the angle is 90 degrees, the force is maximum, and the direction of the force is shown by the third finger, which is perpendicular to both the magnetic field and the current. This is called Lenz's law. So, when the magnetic field is in this direction, the current is in this direction, the current will experience a force as shown by the third finger, and the magnet will continuously rotate. This is a simple DC motor, and the material we require is a cell, two rubber loops which we have taken from the old cycle tube, two safety pins, a big one, a coil specially made, and ring magnets. Now this coil is made by about 22 gauge enameled wire by winding about 10 turns on this cell and then taking the ends out as shown. Now with the help of blade, I remove the enamel from half the portion of this pin as well as half the portion of this pin. This is very important. both the portions which I have removed should be on the same side. That is either on the top or on the bottom. Then I start the assembly. So I first put this rubber band, and then put the pins in between the rubber band and the sail so that their loops are on the upper side. So I put now the second pin, then I put the magnet. Sometimes the sail are paper sails, so the magnet will not fixed on this. For that you may need this second loop. But this sail is made of steel, and so the magnets can be put on this without any difficulty. Then this coil is inserted and you will see that this motor is spinning. Now how this motor works? Now when you put the coil, the current is flowing through the positive, through the coil to the negative side, and this circuit is completed. Now this magnet has its own magnetic field. So this magnetic field will react with the current and will produce a torque on the coil, and the coil will rotate. This is a principle of a DC motor, and with this very simple material you can demonstrate how a DC motor